Welcome to qnawire.
Problem 734. An object moving in the xy plane is acted on by a conservative force described by the potential energy function u of xy is equal to alpha 1 over x squared plus 1 over y squared, where alpha is a positive constant. We are supposed to derive an expression for the force expressed in terms of unit vectors I hat and j hat. So what we've seen before is we would use equation 716, where you have the force of x as a function of x is equal to the negative derivative of the potential energy. So here we just have two variables here. So we're going to do these for each of them individually, and we'll just combine them into the unit vectors. Okay, so in order to find the force in the x direction, we're just going to do this here. So we have negative d over dx, u of x, y, and that's going to get us negative of the derivative of this value right here. So we have negative d over dx alpha 1 over x squared. Now what we could do is we could write down what the derivative of a function that has a term with y in it. But since the derivative of something that's a constant, because it's not changing with x, is going to be 0, I'm just going to leave that out here. But then this should just be negative alpha, and then derivative of 1 over x squared is going to be negative 2, 1 over x cubed. Okay, so then that's going to get us a value that is 2 alpha 1 over x cubed. Now we can do the same thing for y, and this time we're going to write negative d over dy, u of x y is equal to negative d over dy. Now again here, this first term, it's not changing with y, so that's a constant, and the derivative of that is going to be 0, so we just have the other term. So 1 over y squared. Okay, and so we're getting the same thing but with a y, because it's this exact same formula but with y. Okay, so we have our force in terms of x and a force in terms of y. Now we just need to combine those into expression in terms of unit vectors I hat and j hat. So now we have f of x comma y is going to be our f of x in the I hat direction plus our f of y in the j hat direction. And that's just going to be 2 alpha 1 over x to the third plus I hat plus 2 alpha 1 over y to the third j hat. Okay, so that could be our solution there, but if you want to try to make it look prettier, what you can do is you can bring out the 2 alpha, because those are somewhere between the terms, and you could write alpha 2 alpha of I hat over x to the third, or have 1 over x to the third I hat plus j hat over y to the third. Okay, and that would be your force expressed in terms of the unit vectors I hat and j hat.